In this screencast, I'd like to look at matrix multiplication. First thing I want to do is show you that matrix multiplication is really just a linear combination of columns. For example, if I take the vector 1, 2 and double it, and take the vector 3, 1 and triple it, then really this means I've taken the vector 1, 2, doubled it, taken the vector 3, 1, tripled it, and if I add them up, I get a linear combination. Well, that linear combination we're going to rewrite as the matrix equation. I'll write the column 1, 2 as the first column, the vector 3, 1 as the second column, and then I'm going to put the coefficients 2, 3 as a vector, and this is now our vector of coefficients that will multiply by the columns of the matrix. This is precisely what is meant by matrix multiplication. When you take a matrix and multiply it by a vector, you're getting exactly a linear combination. And of course you can always perform the multiplication. 2 times 1 is 2, 2 times 2 is 4, and then I have a 9 and a 3 here, so this gives me an 11, 7. So the answer is 11, 7. So now I want to look at matrix multiplication where I have something bigger than just a vector on the right. So the idea, I'm going to take 1, 2, 3, 1, and let's multiply it now by 2, 3, 5, negative 1. Well, the idea is this first column is the coefficients that I should put in as a linear combination. The second column also gives me a bunch of coefficients I should put in as a second column. So what we're going to do is we're going to take our matrix, I'll call it A, and I'm going to take the matrix A and I'm going to multiply it by 2, 3. Then I'm going to take the matrix A and I'm going to multiply it by 5, negative 1. This is precisely what is meant by matrix multiplication. I'm just creating linear combinations of the columns of A using these as the coordinates to multiply by when I'm creating those linear combinations. So here, I'm going to take the 2 and the 3, and the 2 should be multiplied by 1, 2. The 3 should be multiplied by our 3, 1. And then I need to, again, I'll use a 5 and a negative 1. The 5 should be multiplied by the first column, 1, 2. The negative 1 should be multiplied by the second column, 3, 1. And I already did this one. This was 11, 7. So now let's take this. We get a 5, 10. And I get a negative 3, negative 1, giving me a grand total of 2, 9. That is our matrix. Matrix multiplication is precisely linear combinations of columns. There are two other ways to view this, and I'd like to show them to you. One involves taking rows and dotting them with columns. So this is the row dot column approach. The idea, I'm going to take 1, 3, 2, 1, times it by 2, 3, 5, negative 1, and I'm going to create a new matrix. The matrix is going to be found by taking our row and dotting it with a column. So if I take the first row and the first column, I can take the row and the column and dot them. That'll get me the first row, first column. If I take the second row and the first column, that'll be the second row, first column of my new matrix. If I take the first row, second column, 1, 3, 5, negative 1, or I take the second row, second column, and dot them, that'll get me the entries in the new matrix. Now, if I take 2 plus 9, I get an 11. If I take 4 plus 3, I get a 7. If I take 5 minus 3, I get a 2. And if I take 10 minus 1, I get a 9. I get the same matrix. It doesn't matter how I did it. Last approach. This one basically takes the first idea, and instead of looking at everything as columns, it says, let's use rows. The idea is I'm going to use linear combinations of rows of the second matrix using the rows of the first to create the linear combinations. Let me show you the idea. I'm going to take the vector 1, 3, 2, 1. There's our first matrix. And then we're going to take the 2, 5 and the 3, negative 1. Think of everything now as row vectors and create linear combinations of 2, 5 and 3, negative 1 by using the numbers 1 and 3 to form the linear combination. I'll do the exact same thing here. I'll take a 2, 5 and a 3, negative 1, and I'll use the 2 and the 1 to form the linear combination. Well, now if you look at this, you have a 2 plus a 9, which is an 11 again. You have a 5 plus a negative 3, which again gives you a 2. And then here I have a 4 plus a 3, giving me a 7, and I have a 10 plus minus 1, which is 9. So again, you get the exact same matrix. You can think of it as linear combinations of columns, rows dotted with columns, or linear combinations of rows. That ends the screen.